Okay, so now we're ready to find the volume. Volume of a box is given by length times width times height. So in this problem, our sheet of paper had a length of 11, but remember, we had to cut out the corners. So now our length is decreased by the amount that we cut out. And we don't know how much to cut out to maximize the volume, so we're going to call that x. So our new length is 11, but we have to take out x on each side, so we have to take out 2 x's. And then our width will be the same way. We had 8.5 inches along our sheet of paper, but we cut out corners and folded up that side. So instead of a width of 8.5, we're taking the 8.5 inches and we have to take off 2 x's there as well for this piece and this piece that got cut out. And then when it folded up, our height was this amount of x. So our volume is length times width times height. Now we'll go in and put that into the graphing calculator so we can see what actually is the maximum volume and what x value we should pull out of the corners. So this is the Desmos online graphing calculator. It's free at desmos.com. And so I'm going to type in our length times width times height. So we have 11 minus 2x times 8.5 minus. Okay, so now we are going to graph our equation for the volume of the popcorn box in the online Desmos graphing calculator that's free at desmos.com. Okay, so we are going to enter in our volume of 11 minus 2x times 8.5 minus 2x. That was our length times our width times our height of x. And so here you can see the graph, and I'm going to show you the settings that I have in case you need to make adjustments to your graph. It's set at about -2 to 8 and about -17 to 111. So if you have some settings similar to that, you should get a graph that's like this. All right, so let's look at our maximum volume here. Looks like it's the highest. The volume is the highest at 66.148 cubic inches when the x value that you cut out is 1.585. So roughly